I must admit, I'm not like, yeah, super wide awake this morning, but it's good to be here though. Thanks for inviting me on.
Yeah, I'm really excited because I sit in your stream and I lurk a lot, but to be completely honest, when I'm in stream on anywhere, I'm usually like lurking and working. I'm like queen
Yeah,
of the
sure.
lurk and work. So I don't really like know anybody very well. And we had chatted at TwitchCon, and I found your background and research so interesting, and I'd really like just love to hear more about it. And I know you'd mentioned the CMB stuff during your PhD research, and I first learned about that in geochem, and I was just like, oh my god, that's so cool. And I don't know how much you've shared on your stream about it, but I thought that that would be something really cool to talk about and learn more from you, and how you got to where you are, why you wanted to, you know, do I don't are you planetary geologist, astrophysicist, cosmologist? How do you call yourself? What do you do? Tell me all the
uh,
things.
so right now, I describe myself as a recovering astronomer. Uh, I so my PhD is in astronomy. Technically, the subject is astronomy, or the department is astronomy at the University of Illinois. But it was in cosmology. Yeah, so I did work on some X-ray astronomy in my very beginning when I worked with one of the professors at the university when I was still trying to figure out what I wanted to, what I wanted to do research on. Um, so yeah, I have a few papers about X-ray. We were looking at white dwarf stars and stuff like that. Anyway, and then another professor came, joined the department, and was a cosmologist, and yeah, it was great. I mean, he was young and enthusiastic. He was actually younger than me because I didn't go straight to grad school from undergrad. I worked for 5 years.
Oh, so you went to
Um,
industry, and then and industry you
yeah,
don't mean NASA. What did you
I
do?
went. I went to the dark side. Yeah, I went to Wall Street.
What? Oh, okay, now I really have to ask. What made you go from like and I'm really thankful because you would just not look good in a puffy vest. But like, what made you go from finance bruh to like awesome scientist?
um, so let me see. So my undergrad is in engineering. So I went to the University of Cambridge in England and did an undergrad in engineering. Mostly played rugby and did a bunch of other stuff that wasn't really very academic while I was there. But I did end up with a degree at the end of it. So um, and I kind of didn't really know what I wanted to do. And then yeah, there was a bunch of banks in London hiring, and I got a temp position with one of the big investment banks, and ended up being taken on permanently, and then ended up working for them in Japan. So they were looking for somebody to head up their risk management department in Japan for the trading risk management. And so I was like, I didn't have any particular ties in the UK at the time. I was like, yeah, I'll go to Tokyo, sure, why not? So I just kind of hopped on a plane and went to Tokyo, and
That
that was 2 years. So
that's so
it was
incredible. I'd be so afraid to do that.
yeah.
That's so cool.
I had traveled quite a lot before that. Like I had a gap year between high school and university where I traveled quite a bit, and then but arriving in Tokyo was definitely one of the biggest like culture shocks I've had, just in terms of nothing being in English. Like not once you leave the airport, like I had an apartment somewhere, I had to find my way here and there, and there was very little signage in English, and it was kind of like, oh wow, this is very different. But
That's
I loved it though.
terrifying.
Once I got used to it, I loved it. The company had paid for me to learn some Japanese, so I could speak some of the language, and enough to get by anyway, like do groceries and whatever, get a taxi to take me where I needed to go. Um, and yeah, while I was there, so I was doing that. It wasn't. I would say it was fun. It was a high pressure environment. I mean, it was a lot of smart people, but it was maybe not super like intellectually stimulating. Uh, and so I ended up taking up amateur astronomy as a hobby. I met these Japanese guys who had a shop in where was the shop? In Shinjuku, I think the shop was. Uh, and so I got to know them, and they spoke. The guy that owned the shop, Murakami-san, spoke some English, and we kind of became friends. And I bought a telescope from him, and then they used to take me observing with them, and they were like super. They had these little, like, most Japanese people drive fairly small cars, right? Because having a car is really expensive and parking is really expensive, and most people don't really need a big car anyway. But they used to drive these little cars up to Mount Fuji, and there's a parking lot. It's called the Fifth Station, Gogome. It's where most people park before they hike to the summit. Like, people go
Oh,
there in the night and they hike up to watch the sunrise from the summit. And they would go park in this Gogome parking lot, and then the back of the car would open up, and they would get out all these computers and generators and power stuff, and they would do CCD astrophotography from this parking lot halfway up Mount Fuji. It was so cool, and I was hooked. So I used to do that with them a little bit.
that sounds amazing.
Yeah, it was super fun, and so we did that, and it was really cool, and I kind of really got into the astronomy, and then I was like, oh wow, I this would be a this would I'm really this is really interesting. I want to learn more about this, and then I did like a online class. I mean, it was the very early beginnings of online classes, so it wasn't really online as such. It was just email, like, with the instructor and stuff. I think it was University of Lancashire or something like that. It was one of the very first. It would have been like 97, maybe 98, somewhere in there.
Oh wow, that is really early because I started taking classes online in like the early 2000s, but not even
Yeah.
the 90s, like 2005 or something.
Yeah, this was like the birth of online.
Wow.
Uh, Before that, you could take these correspondence courses, right? There was a thing in England called the Open University, and they would mail you stuff. You would do the assignment and mail it back, and it was like an analog sort of
Yeah, I've heard of that.
way of. Yeah, yeah. Uh,
I think we've got some questions in chat. It looks like your community wants you to do a redeem financial advice with
oh
unnecessary
gosh.
brand hype and also a Wall Street bruh costume. I would
The
I
Wall
would
Street.
donate bits or a gift sub to get to you see you in a Wall Street bruh get up.
Yeah,
I would.
I did used to wear a suit to work, I will say, and I still do own suits, but I don't. I've sworn not to wear them except for like.
Oh no no, it's the puffy vest and the shirt and the
Oh, the vest
khakis
and the
and
polo,
the
the button down and the yeah, 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 yeah,
yeah
yeah.
yeah. You got to walk
Uh,
around like a alpha male, you know.
so one of the things, like, with finance, so after I left JPL, I actually worked as a financial advisor for a couple of years as well, and this is a whole other story that we don't need to get into right now. But actually, giving financial advice is so heavily regulated; it is insane. And so that's one of the reasons, like, just trying to, like, having a redeem to give financial advice on stream. It's like, I don't know, like,
Oh no,
you could give
I
you could give
totally
generic
understand
financial
completely.
advice to people, and, like, one of the thing people always like, well, what do you do if you win the lottery? Do you take the money, or do you take the cash, or do you take, like, the payments? It's like, you always take the cash. Always, if you win the $1 billion, take the money. Yeah, it's only 500 million or whatever, but you're way
You
better off.
get it instead
That
of
kind of
having
thing you
to.
can tell people, but yeah, specific financial advice to someone's situation, you have to be licensed. You have to have you can't have a website. You can't. It's completely crazy. Science education and outreach is so much easier. And it's a lot more fun, in my
It's a
opinion.
lot
But
less regulated for sure. Although depending on what you say, people will come at you though. Did you see Michael Mann just won his lawsuit, which is nice.
I
That's very
saw
very
that.
very
Yeah,
refreshing and makes me feel a lot better.
it's good, but I mean, it's a shame that it just all this stuff takes so long.
I know. I
But
know.
yeah, it's
Hi,
great that he
Curtis.
was vindicated, and
Yeah. So
uh,
I think you have
but yes.
to dress up. Thank you for the
Just,
lurk
I could definitely
seeds.
do that. I could definitely do that. And
So
but yeah,
so
so and I met this professor. He was so I used to ride motorcycles as well, and this is a whole other side story. But I used to ride motorcycles in Japan on the weekends because it was uh, having a motorcycle. Parking for a motorcycle was way cheaper than parking for a car. I think parking for a car
that
was
makes
like
sense.
800 or $1,000 a month or something for the parking space. Right? Everything in Tokyo is massively expensive. And the company was paying for my apartment, but they wouldn't pay for a parking space for a car. So I'm like, well, that's stupid. So I had a motorcycle and used to go riding with these guys. It was a couple of Italian guys and then a bunch of Japanese guys, and we would ride off into the mountains and go to these, like, tiny little restaurants in these little villages. Uh, and nobody spoke English. Not, the menus were all in Japanese, so they would like order for us and stuff. It was super cool. But I met this professor of astronomy from the University of California, San Diego, and I got chatting with him, and I was like, "Well, this is kind of cool. Like, do you think there's a way for me to go back to school and study astronomy?" And he was actually really encouraging. He's like, "Yeah, I don't see why not." He's like, "You have the background. You'll probably have to take the GREs, just to show that you know something about physics and astronomy and and math and whatnot." But he's like, "I don't see any reason." So I kind of started on this journey to find a university that would take me.
So how old were you when you started grad school? Did you go right into a PhD or did you do a master's first?
Yeah.
And how old
Wh-
were you?
So it was a PhD program. I started in 1999. So uh, I would have been, I don't know, 28, I guess. I was born in 1971, so you guys can do the math. It's early for math. I guess I was 28, yeah.
Okay, that's I mean that's older than normal, but like I think 20. Oh no, also 28 when I started my PhD.
Yeah, I think it's become much more common. Like when I finished my undergraduate degree in the UK at Cambridge in 1990, whatever it was, four, I guess, it would have been almost impossible for somebody to leave and think about coming back because it was like there's very much this mindset that you had to continue and your brain had to keep going. And there was this thing that historically, most people had done their most uh, productive work and made their biggest contributions to science when they were very young, right? It's very early in your career when you tend to make these big discoveries, and you don't have all this baggage that you do later where like you're worried about what people think and all this other stuff. And so there was a lot of inertia against people leaving and then coming back to do a PhD. If you wanted to do a PhD, you finished your undergrad and you went straight into a PhD program, often at the same institution.
And is that UK kind of is the
It
same
was it
institution? Is that because in the US it's kind of
different, yeah.
I'm gonna get to chat in just one second, Ningao. In the U.S., it's pretty frowned upon to stay at the same
Yeah,
place. They like
it
you to
is. Yeah.
bounce around and go to different universities and work with different people to show that you're not just in one spot.
Yeah, and I think it's changed in the UK now as well. I think it's very. I mean, this was 25 years ago, right, or more
Okay.
even. So it's things have definitely changed, and I think there's less stigma attached to like wanting to do a PhD when you're a,
A grown up.
academically ancient at like 28 or 30 or something, right? uh,
So we've got some questions in chat. I want to pause and looks
sure.
like there's a lot of people that are interested in the money things.
Uh,
Ningao, I read Starter Villain. No, dude, I haven't read anything except for academic papers in long time. But also, I like reading the academic papers. I don't have time to keep up on research and do reading for fun, but I really enjoy the keeping up on research, so it kind of balances out. And then we have a question. Welcome, Ponder Monkey. Your wife is flying to Iceland next week. Should you be concerned? No. I would not be concerned at all. The eruption in Grindavik is very passive. I would not expect it to be anything like Eyjafjallajökull in 2010. As long as she's staying away from the area where there's an eruption, she'll be absolutely fine. I don't think that it would probably impact her in any way, although, the Blue Lagoon is the biggest tourist attraction, and that is closed because that is where the eruption is. Because if you were gonna pay $66 to go to the Blue Lagoon anyway, you're wasting $66 to go take a bath in power plant wastewater. So save your $66 and you're fine. Um, I just if you didn't well, so the Blue Lagoon is like this like geothermal spa, and it's like this huge attraction, but like it was only made because they had wastewater and some people found out that like their eczema got cured, so they decided to like really put a bunch of money into it, and now it's like the country's biggest tourist attraction, but it's all wastewater from this power plant.
nice.
You're just paying a bunch of money to hang out in wastewater. So yes, yeah, Ponder Monkey, I would not worry about it at all. Yep, no worries. So when you started your PhD, Nerdwino,
Yeah.
what did you focus like? you were interested in cosmology already. What did your advisor like give you a project, or did you kind of like explore what you were interested in? How did you like figure all that out? If I post
Yes.
some of these answers to Blue Sky, that would be great. I can do that. I'm gonna go back through this, Patrick, and I will do that for sure. Hmm. Sorry.
No, yeah, no worries. Yeah, so obviously, like, it was a bit of a culture shock going from Tokyo to Champaign-Urbana. Um, and yeah, so that, as you know, there's qualifying exams, right? For the to do your, when you start doing your PhD, there are qualifying exams that you have to pass at some point, typically within the first couple of years. I don't know about your programs, but the astronomy program, Illinois, you had three chances. You got what they called a free chance when you first arrived. You could take the quals, and if you passed, they were done. And then you took them at the end of your first year and the end of your second year. And if you have to pass one of those times, you had to pass, and you had to take a physics qual and an astronomy qual. And you could pass them, like, if you passed the astronomy one year, then you only had to take the physics next year, whatever it was. And so, and so I had just come from Japan. I hadn't done physics in, like, 5 years or whatever. And they're like, "Well, you have this free shot to take the qual. Do you want to sit it?" And I was like, I don't know. Sure, why not? So I think I got like 45 or 50% on the astronomy qual, which wasn't bad. The pass, I think you only had to get maybe like 75% to qualify.
Well, and for
So,
not
so
studying and just sitting and taking it, that's
yeah,
not bad.
exactly. I was like, this is fine. I can,
Yeah,
I can,
you can
I can.
improve.
This is doable. The physics, I don't remember the exact percentage, but I think it was less than 5% that I got on the physics qual. And so this obviously caused a little bit of consternation amongst the faculty and the department, which nobody ever said anything to me, but I just knew. I was like, "Ooh, this isn't good." Uh, and so that first year, I took a bunch of. So I'd never taken quantum mechanics, for example, right? Because I did an engineering undergrad, and quantum mechanics just wasn't relevant. So I took like a quantum mechanics class. I took some thermodynamics. I basically beefed up some undergrad, like upper level undergrad physics classes. Um, and studied really, really hard. And so the first year, there was just kind of that, and doing the astronomy. I had to take the astronomy classes as well. And then so the next year I took the qual, I passed both, and I think there was a general sense of relief. So once that was over, then then there was more professors who were willing to be like, "Oh yeah, you can come and work for me," kind of thing,
Okay.
as opposed to like, "Well, you're not going to be here very long," so like,
We have a question in chat for you. Can you go from an absolutely unrelated field in undergrad, which sounds like you did, kind of engineering, to astronomy in grad school via exam scores, or would one have to pursue prereq credits? Probably the prereqs too,
It
right?
totally depends on the institution, I think. But I would suggest that, like, I wouldn't have wanted to go from like English literature to astronomy. I think that would be really, really hard. Engineering, if you're doing something mathy, yeah, there's no reason why not. And like, if you're, say, a biologist, for example, right? There's now astrobiology. I mean, back in those days, astrobiology was just a very uh like a nascent sort of thing. Whereas now, yeah, there's all kinds. There's astrobiologists, astrochemists. So if you're
Mm,
doing one of these other subjects, yeah, I think the math, as long as you have the math background or some math background, and you don't mind suffering a little bit through the pain of learning the rest of the math that you need.
yeah. I think it's the
Yeah,
catching
it's
up.
doable.
One of my good friends got her PhD in climate science, and she does paleolimnology. So that is the study of old lakes, if you're not sure what that is. And she started out with an English degree in undergrad. So, but she also like did struggle a lot with the math too. I know I
Yeah,
do as well. But
I would say the more unrelated your undergrad is to whatever you want to study for PhD, the more pain you have to be prepared to put up with, and the more determined you have to be that you're going to do it, because it's pretty brutal. Like, the first couple of years of grad school were rough, really rough. Like, I thought about giving up.
mm-hmm. Same.
Which even people who have did physics, like, there were people that had physics degrees who didn't make it. I think my
Mm-hmm.
class, there was 9 or 11 of us, and only 5 got PhDs in the end. Lots
Wow.
of people, several people got their masters and were like, "Yeah, I'm out. I've seen
The
enough."
master out.
Yeah.
Yeah.
So
So what project did you eventually start on when you
okay, yeah.
finally?
So the one professor who I kind of talked with when I first applied was working on this white dwarf stuff. So I was studying these white dwarf stars. and which is like the end of the stellar evolution curve. And there was some thought back then that maybe the white dwarfs could be the dark matter that we were missing in the universe, right? There's dark energy and dark matter, and dark matter is just like is normal. We think normal, but it's baryonic matter that we just can't see. And so what people were thinking, well, if there's white dwarfs out there that we can't see because they're too dim for us to observe, maybe they could make up for some of the dark matter. And so we were using various techniques to try and find where these white dwarfs might be without being able to see them, that kind of stuff. And that was pretty cool. That was pretty interesting. So I published a few papers on that early on, and then back towards the middle of my, a couple of years in, maybe I think it took me 6 years to get my PhD, and I want to say for about 3.5 years I was working on the cosmology stuff. So yeah, then this new professor came who was a young cosmologist, cool guy. We got on really well, and he agreed to take me on as one of his grad students. And so I started working with him, and also he had some money as well, so I was able to get a research assistantship from him. Before that, I'd been teaching,
Oh,
so
nice.
which is
Clutch.
okay. I mean, the teaching is great; it does pay, still pays the bills, but it's a it's an extra thing that you have to do that isn't moving you forward on your PhD necessarily. Although it was really cool, like working with the students and doing observing sessions at the observatory and showing them Saturn and all that stuff was really cool. I enjoyed that, and that's part of the thing that sort of led me into science communication and outreach now, is that I enjoyed that aspect of it quite a lot. But in terms of getting the PhD, having that research assistantship was huge. Yeah. So
Oh yeah, I mean it allows you to actually just like focus. It's
yeah,
really
just
hard when you're dividing your brain and your energy.
exactly,
Um,
exactly.
we
So
got
that
an
was
ad
sorry.
coming up in a minute, so I think we can
Okay.
maybe do a
Well, let me
question and take a little.
yeah, let's do that. That
Yeah.
sounds good.
So go ahead and let's chat. Big swole brand. Blah, 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 no questions in chat. So when you published your first paper, how many papers did you publish before you got your PhD?
I don't I don't remember, a half a dozen maybe. I probably had four first author papers by the time I got my PhD, and a bunch of like second and just third or whatever. The kind of I was probably on maybe 10 or 12 papers by the time I
That's a
finished.
lot, dude. Holy crap.
Yeah, yeah, it was good. I mean, I had a pretty good publication. So I think that was one of the things that helped me get. Um, so I got well, we'll get to it, but I got an NSF fellowship when I finished my PhD to basically take wherever I wanted and do whatever I wanted with. So that was kind of cool. And I think
Oh
that
my
publication,
god.
yeah. So anyway, the guy that I was working with, we kind of came up with this idea for a PhD. He had some uh, ideas for like some new math, or not new math, but using Bayesian statistics basically to try and remove. Okay, let me take a step back. So the cosmic microwave background is this leftover radiation from the Big Bang, and um, it's everywhere on the sky. Like it's the same temperature with very small variations of about 1 part in 10 to the 5. So you're trying to detect this tiny signal on the sky, and mostly it's done with satellites. I did work on a ground-based experiment called BEAST, which was the Background Emission Anisotropy Scanning Telescope, I think, which was a project for the University of California, Santa Barbara. And I
Mm-hmm.
was in Illinois at the time, but we did the data analysis with them. So I did that. We worked on some real data. That was cool. We did manage to get a result, which we published. Just so then there were some satellite missions to measure this radiation as well. Kobe was the first one, and people got Nobel prizes for the Kobe stuff. And then WMAP was the next satellite to do this, and then Planck was the most recent satellite that measured the CMB, and with increasing sort of resolution, and some were measuring polarization and various other aspects of the CMB. And then there were a bunch of ground-based things going on at the same time. And so my PhD was basically that beast work, and then we came up with a new method for removing foregrounds from the CMB. So the problem with the CMB is we're on the Earth, right, which is in the middle of this big galaxy, and there's all this emission. So I don't know if you can find a. Let me see if I can
Oh
find
yeah,
an
I was
image.
actually gonna ask if you can share your screen and we can show people in chat,
So
because I know
like,
some people might not be familiar with what the cosmic microwave background radiation even is or looks like or anything.
yeah, let me see if I can do that. Share this. Okay. Did that work or no? No, I'm missing
Yes.
that. Oh, okay. So can you see? I don't have your stream up anymore. Where's your stream gone? Ah,
I'll pull it up.
well, I got you. Okay, I see you. Okay, so that's the image. Yeah, here we go.
Oh, their screen share went away.
Oh, it did.
Yeah.
Okay, here, let me send you the. Maybe I'll just send you a link and you can just bring it up in a browser on your
Okay.
screen. So there you go. That's the CMB.
In Are you sending it via Discord or Twitch?
Oh, I just put it in chat. I just put it in
Oh,
chat.
that would make more sense, huh? Um, Now I have to find my chat. Oh, can you send it to me in Discord?
Yep,
Because I've got
sure.
links disabled.
That's
Sorry. There we go.
okay.
Yay! Alrighty. I'm gonna put this as a browser source in here. Okay, here we go. Cool. I've got the CMB picture up. It's covering my face, so all we can
Okay,
see is
we'll
your
talk about it real
beautiful
quick, and then
science.
yeah. So this is the CMB as observed by the Planck experiment, which is what I worked on. One of the experiments I worked on. That's what when I went to the Jet Propulsion Lab. This is what I worked on. And so these are the tiny fluctuations in temperature that you observe when you look at the cosmic microwave background.
So what is cosmic microwave background? Because like it sounds like you're just trying to put some space in a microwave.
So the reason that microwave is the frequency that it's observed at. That's why it's called the microwave background, because we see it
Ah,
now. So it was thermal at the time of when it was emitted, and now it's been redshifted into microwaves.
okay. And
And
so I
so
think, am I
it's
correct in thinking that like at the Big Bang, the universe was like, what color was the universe then, and then did it go through all the different wavelengths of light and light and be like red, orange, blue, and then now it's in microwave, or how does that work?
yeah. So the when the universe 15 billion years ago, right? 13.8, whatever the right number is. We're not 100% sure, but it's somewhere in there. Um, we have this model that the universe started from the Big Bang, when the universe was kind of infinitesimally small and hot and dense and uniform. And we have this Big Bang, and we have inflation, which happens, um, that takes the universe from being very small to being very large. And we don't have a great explanation for how that works. We just think that's one of the few theories that can explain the things that we see. And so we think that the baryons and all the normal matter, right, were formed in the first few seconds, and then the universe expands, and it's like a plasma until about 300,000 years. And then at this point, about 380,000 years, the universe cools enough that the protons can capture the free electrons that are just in this plasma bouncing around and stopping light from being able to travel any very long. The mean
Oh,
free path is really short. The protons capture the free electrons and then form hydrogen, right? It's just a proton and electron. And then that's called recombination. And so after recombination, which is around a redshift of 1100, which means the universe was 1100 times smaller then than
than it
it
is
is
now.
now. Yeah. Um, and then we can, and then sorry, and then the the radiation then can start to travel, right? So light can start to travel through the universe as well. And so at that point, what we see it today as a signal that's at 3 Kelvin.
3 Kelvin. So that's
Yeah,
like almost zero.
2.73, like whatever, but it's almost zero. And then, but in the CMB are imprinted these tiny little fluctuations, which is what you can see on that map.
They're temperature fluctuations, and that's what we're
Temperature, yeah.
seeing
This
on
is
here.
well. So the idea is that these are temperature fluctuations, um, and and that corresponds to density fluctuations in the matter in the universe.
Mm-hmm.
And so the idea is, if you can track, so where it's hotter, you would expect the universe to be less dense, right? And where it's colder, so the blue, you'd expect it to be more
More
dense.
dense.
And the idea is that these would then be the seeds of like structure formation, where you would expect to see clumps of matter in the blue areas, maybe, for example.
Oh, that's cool. I never put that together. That's really neat. So we've got a bunch of questions in chat. I'm really glad that we're getting to talk about this because I know that like I found this so cool, and I knew that like if I found this cool, a lot of other people probably would too.
Yeah.
Um, 3D wants to know why is there a hole inside?
Like the thing in the middle that's blue, you mean?
I
Is
think
that what you're
so.
Yeah, it's just your eyes seeing. If you look, there are actually patches of hot as well. So it's just random. It's not. So there are some statistical anomalies that we've observed with the CMB, things that we can't explain. But what you expect if the universe is homogeneous and isotropic, right, which is the cosmological principle, it should look the same in all
But
directions.
it doesn't.
And but and so on large scales, it kind of does. But there are a couple of features of the CMB, which it does seem to have a preferred direction, and explaining why it has a preferred direction is not straightforward, because you wouldn't expect that it would. But then you have to worry about things like foreground removal, right? So let me see if I can find a good map of CMB foregrounds. But you do have to be careful when you look at things like this, that your eye is really good at filling in details that just aren't actually there. Like
Mm.
your eye is not very good at doing statistics. It tends to focus on stuff that looks different to it, when in actual fact, because if you look at that big blue patch, there's actually a big red patch just to the right of it as well, right? So it's
Yeah,
like,
I can see that. Like, oh,
yeah.
I guess you
So
can't see my pointer.
no.
Um,
So let me see if I can find you a good image of what the CMB actually looks like. Oh yeah, this is good. Oh yeah, that's true. This is a really good website actually. So if people are interested in the CMB, uh, Wayne Hu has an excellent paper, or a website that has a bunch of stuff going from very simple models of the CMB to how it formed and all the way through, and he has animations, and it's really cool. And it's here, I'm going to send you the link to this paper
okay.
where you can see the foregrounds, and then the hold on one sec, I lost your
I
thing
tried
there.
to do permit links in chat. I don't know what I'm
Oh,
doing.
it's okay, it's all good. I think this, so that's the paper, and I can show you the foregrounds in that PDF file. But then I think if see if Wayne's thing is still here. It
Oh.
looks like it is still here. So this is actually, like, this website, Wayne Hu's website, is really cool. And you can learn a lot about the CMB
Mm,
there. So if you go
uh,
down to page 3, I guess it is, or page 4, where that has those maps of the CMB.
I'm gonna put this in chat too. That way, you guys, there's a lot of. Oh wow, cool. Hang on, I'm gonna change my. Can I do that? No, I cannot. Um, window capture. No. Display capture. That's what I want. Seriously? Uh, come on. This is the worst. There we go.
Infinite Nerd, we know. Okay.
There we go. Hui. All right.
Oh yeah, so if you just go up to the just one more page up,
Yeah.
so those are polarization. We don't need to, we're not going to get into polarization. Those maps there. So that is when you actually observe the CMB. Those maps that you see there with the so that's the galaxy that you can see.
Mm-hmm.
And so you have to figure out, and those different frequencies. So it goes from 30 gigahertz to 857. These are all the different frequencies that Planck observed at the low frequency instrument and the high frequency instrument.
Wow.
And but you can see that, of course, because we're observing from the middle of a galaxy, our sky is dominated by that emission from the galaxy.
Mm-hmm. So that's
And
why in the at the kind of like the equator in the image, it's always going to be a little bit strange.
yeah, exactly. And if you look at the original CMB map that we looked at, there's none of that in there. And so removing all of these foregrounds, so there's dust and there's other kinds of emission. There's all kinds of, there's like at least, I don't even know, let's say 8 or 10 different dominant foregrounds that you need to remove
Mm-hmm.
to get to the map that you see there, right?
Yeah.
And so my PhD was focused on techniques for removing those foregrounds.
From
And some people
getting
are interested.
from
Some
like
people are
taking
interested
all
in
of
just
these and processing them and like getting all the mixed up stuff together to make this final
to,
picture.
to basically. So you would expect the CMB signal to be the same in all the frequencies, right? Because
Yeah.
it should be constant. But these foregrounds are different at different frequencies because different foregrounds are dominant in the different bands. And so
Mm-hmm.
you can use this multi-frequency information and a bunch of other techniques, statistical techniques, to remove these from the data and
Hmm.
hopefully. But you never know if if you've done it perfectly or if you've introduced artifacts. And so it's a huge computational challenge as well to actually to do this and then extract what's called the CMB power spectrum from this, which
And
I
that's what this is. The
yeah, so this is the actual map of the CMB. This is the CMB as observed by Planck. The clean, this is what you would call a clean map. So,
okay. Okay.
yeah.
Representing the seeds of all future structure. That's so cool. That's
We,
so cool, dude.
yeah.
I can't get over it. That's just so cool.
And so this is some of what, if you've been following, like JWST recently is making these discoveries, and people are saying, oh, well, galaxies are forming too early in the universe, and we have huge galaxies,
Mm-hmm.
400,000 years after the Big Bang, which shouldn't be possible. And so, you know, uh, it, so there's a lot of challenges, and the CMB is just one snapshot, right, of the early universe. There's many other measurements that you can use, and now I was talking just yesterday. Actually, the South Pole Telescope, which is one of the ground-based efforts to measure the CMB, has is now measuring gravitational lensing of the CMB in an attempt to try and find again dark matter.
And gravitational lensing, is that where like space bends?
Yeah, it's an effect. Yeah, exactly. Right. So
Okay.
so the a big clump of matter basically makes a lens like a gravitational lens and actually bends the light around it, and you can observe it.
Cool.
Um, so yeah, it's pretty cool.
Cool. Got it. I'm gonna catch up
Uh,
and shout. Look, we've got a bunch of questions about that. Oh my goodness. Okay. How many people were working on this at JPL?
JPL. So JPL for the Planck mission, JPL was the was called the U.S. data center. So we we worked with a bunch of people, some people from Berkeley, some other people. But at JPL itself, there was probably 20 of us, 15 or 20 of us working on it.
Okay. And I know business daddy had to go out for a meeting, but I think they had a quick question. They wanted to say like they try to show this map, the CMB map, and tell people about it, but they look at they get looks like what are you talking about? Is there how would you like recommend if you wanted to just tell somebody about this thing? Like how would you tell somebody about this if they're like, you know,
Like, how do you package it for a non-scientist just to tell them
yeah,
this is
yeah.
yeah, I usually, so I think so Wayne Who's website is really good. That link that I sent for the W Who without the the courses and all that, he has really good explanations on there. I do think that you probably, before you try and explain it to people, make sure that you understand what it is. But I think most people, if you just say, look, this is the leftover radiation from the Big Bang when the universe first became transparent, and we're measuring tiny temperature fluctuations in that background that will tell us things about structure formation in the universe. And those, depending on who you're talking to, you might need to use. small, like shorter words, or just make it more bite size for people. But I mean, that's basically the sort of um, that's the elevator pitch for it, right? And then after that, you can get into the physics behind why there's these anisotropies, why how inflation's affected things. You can talk about redshift and how it was at whatever 3300 Kelvin when the universe became transparent, but now the universe is 1100 times bigger, and so that temperature is now 3 Kelvin where we observe it. And you can get into a bunch of other stuff. The foregrounds. I mean, some people are interested in the foregrounds for their own sake, right? So they're interested in removing the foregrounds from the CMB maps because they can actually use those foregrounds for uh, tracing dust in the galaxy and that kind of stuff.
Oh, that's
So
cool.
there's like all these little spin-off cottage industries of people doing other stuff with the data that uh, is kind of like the junk that people that want to study the CMB want to get rid of is like someone else's PhD, you know.
Mm-hmm.
It's kind of super cool. Yeah.
Yep. Um, and then Ningao, no, background microwave does not cause global warming. No. 3D wanted
Definitely not.
to ask, so the frequency is shifting. At what point would it have been visible? Yeah, it would have been a
Um,
long, long time ago.
I don't know the answer to that question. Yeah, I haven't thought about that, but you could do the calculation and figure it out.
Hmm. That is a good question. How do you bake apple pie from scratch? Entropic, that is a completely different stream, but I can't answer that. Like an orange
You have to
glow. Yeah.
plant an apple seed in the garden, wait for the tree to grow.
I, I will say that whatever you think of apple pie, there is way more butter in there than you would expect, for
Oh my
sure.
goodness. Yes.
All the butter. Swimming in an ocean of light. Let's see. I'm just making sure that we're not getting missing anything. If big brains struggle with streaming, you feel better, Ponder Monkey. Good. We may or may not have big brains. That's subjective, I think, but I know I struggle. I definitely struggle with streaming for sure. Oh, it was a Carl Sagan quote, the apple pie thing. Oh, I'm sorry, Entropic. I didn't get that that was a joke. I thought that that was a serious question. So, so then like how? Okay, so after you when you finish your PhD,
Yeah.
what you got the NSF postdoc, which for people who don't know, that's like the most coveted postdoc. I've applied for it. I'm hoping I'll get it, but like that is
Oh yeah.
the one that
Good
you
luck.
want to get.
Yeah. So the way those work is they agree to fund your research, but you get to do that research wherever you would like. I mean, not exactly wherever you'd like. The institution has to agree to take you, but you're essentially funded. So they're getting a free, you know,
Free labor.
a free postdoc. Yeah, essentially. So a lot of places will take you, but I wanted to, so I was working at the University of Illinois, obviously getting my PhD, and Planck was, uh, the work on Planck had begun. The Planck mission hadn't launched yet. The Planck mission launched while I was at JPL, but so I took that postdoc, and I already had contacts with the people at JPL, and they were interested in having me there. So I was a postdoc at JPL for like 2 years, I think. Yeah, and the NSF thing changed into became like an NRC fellowship. There were some changes in their program halfway through, but it was essentially the same thing. And then yeah, at the end of that, JPL offered. Actually, I was offered two. I was offered a job at Caltech because for those people that don't know, so JPL is a government-funded lab, but it's administered by Caltech for the government. So the Caltech has a contract to manage JPL.
Is it on their
And
campus?
no, it's a separate campus, but
Okay.
like I had an adjunct position at Caltech, so I could go down there, and I used to go to like astronomy colloquia, and I
Mm-hmm.
worked with some people at Caltech on some different projects. It was a really nice um, collaboration. So
I was wondering because I went there. I went there in April to give a talk, and like where their geology department is, and I was like, I don't like no idea
at
where
Caltech.
JPL was in relation to that.
Oh yeah, so they run a shuttle bus. It's about like a 10-minute drive. It's not
Okay.
that far. It's just traffic.
Hmm.
It's probably 5 miles from Caltech.
I was just
Just
wondering.
north up in the hills. Yeah, so it's up there. And so I've totally forgotten what I was going to say about that. But um, Oh yeah, and so I knew. So I was actually offered a position doing astronomy in Caltech and uh, like on Spitzer actually, which was a completely different mission, but it was data analysis. It was essentially doing the same thing. And so and then JPL also offered me a position to work there, and I ended up taking the position at JPL, and I worked on Planck for another probably couple years, and then the funding for Planck started to wind down. The mission, uh, so the because you're measuring these tiny fluctuations, the instruments are typically actively cooled, and you eventually run out of that coolant, and so the experiment kind of dies a death. And there's no way, or there was no plan to recharge the coolant and stuff. There was no service mission, and so as that died a death, then I just kind of became a general JPL scientist slash engineer. Started to become more of an engineer, actually, weirdly. Um, and I worked on a proposal for a lunar lander, like a lunar radio antenna on the dark side of the moon, where it would be shielded from radio frequency interference from the Earth. I worked on SMAP, which was a soil moisture measurement thing. I spent some time building a correlator for that and flying on a twin otter aircraft up in Winnipeg, uh, testing that with a bunch of with a couple of ex Navy F-18 pilots, and that was kind of fun. And God, I don't even know what else I worked on. A bunch of small stuff, a bunch of what they call R&TD proposals. So there's a lot of money at JPL for doing small projects. Maybe you're developing a little piece of hardware that might be useful in the future, or that kind of thing. And you can get maybe like $50,000. Is the typical award for those, which will pay for someone from JPL for about 3 months. It's about one quarter of your time.
Wow.
With the overhead, back in those days, a JPL was costing about 200,000. So 50,000 would fund one person for about a quarter of their time.
So
And so you
what
would,
is the
yeah.
difference? Like what does an engineer do versus a scientist do? Like what is the difference?
I mean, typically engineers have more of a background in hardware, I would say, right? Or so like the guys working on the Mars rovers, for example, they were building the Mars rovers while I was there. We could go watch, and we saw them in the Mars yard testing them and stuff. So most of the people working on the actual rover itself and building it and figuring out how it was going to work were engineers, but the scientists were the ones that said, okay, we want to go here, we want to sample these rocks, and here are the science goals, and now you guys need to go make this robot that will do these things that we need it to do so that we can do the science. So I guess that is
Okay.
kind of like but often those roles blur, and the scientists end up learning a lot about the engineering, and the engineers end up learning a lot about the science, and so it becomes those roles become less sort of you know less clear.
More
Yeah,
intertwined.
I was there when Mark Rober was there. I didn't know him though, but yeah, I was there at the same time as Mark. Yeah, but we never met. But there's
Who's
5,500
Mark
people at J.
Rober?
Oh my God, you don't know who Mark
No,
Rober is?
I don't do like
Yeah, I'm not. It wasn't criticism. I'm like, oh, you have to. It was like, oh, you have to learn. Yeah, he was an engineer. He worked on the Mars rovers, and now he does education and outreach. He has a really cool YouTube channel, and he has a bunch of he has something called Crunch Labs, which is um a cool STEM toy
Oh,
or
I've
like
seen that.
build. Yeah, and so like
Oh,
mini nerd. So my daughter has
she likes them.
yeah, she loves it. Like it came yesterday and it was built within 10 minutes. And he has really cool videos that teach the physics and the engineering behind whatever they're going to build. And so yeah, he's really cool. You should look him up. Mark Rober, yeah. And he lost, I think he had a package stolen off his porch or something. Anyway, that pissed him off and he built
Oh,
these glitter
that guy, the
bombs and
glitter
yeah.
bomb guy.
Yeah,
Oh,
yeah, yeah,
that
yeah.
guy. Okay, okay, okay. Yeah. Okay, that's fun.
So yeah, he's a cool guy. He was there, and yeah, now he does more sort of science outreach and education and stuff, and it's super cool. He has a great channel, and I highly recommend going and check him out on YouTube.
Yeah, I definitely,
And
definitely
if
will.
you have a young person in your life, the Crunch Labs kits, there's like a monthly box that comes, and it's a different thing every month.
What's like the youngest age that they're suitable for?
I don't know. I would think like with parental supervision, probably 5 or 6. Mini Nerd is 10, and she does it on her own now. She's been getting them for about a year, and she would struggle a little bit when she was a year ago. Like when she first started getting them, I would have to help her now. She doesn't need me. So I think I don't know what the recommendation on the website is, but it's just really cool, you know. And the I'm looking it up right now. The videos that go with them and the explanations and stuff is really good too. So yeah, I
I'll
think it's
definitely check them out. I know a lot of I'm at the, I had a kid real young, so mine's
uh,
grown, and then all of my kids or all my friends' kids are like littles. So I don't think I have
yeah,
anybody yet, but in a couple years I will.
probably not for the real littles, but I definitely think pretty young, right? But and you can buy just one, like you don't have to buy the. I think you can buy just one and see if you like it. If I remember rightly, you don't have to sign up for the whole thing. But they also have a Willy Wonka thing where there's a ticket in one of the boxes that gets sent out, and you get to go with a parent to his lab and see all the stuff being made, and yeah, it's
That's
kind of cool.
so cool. Oh, that's so
So,
cool. Oh my god, I love that so much.
but yeah, so Mark was there at JPL. But yeah, like I've never actually had. So I often bump into people. They're like, "Oh, you worked at JPL? Did you know so and so?" And I've never once had somebody name somebody who I knew. So it's kind of like, but there was 5,500 people there when I was there, so it's it's a big place,
Yeah,
it's a huge
it's
campus.
yeah.
I mean, there was a
Um
post office, a bank, three cafeterias. It's big.
Huge.
Yeah.
We have a question for you. How does one get started in radio astronomy at the novice level?
That's a really good question. So there's a bunch of cool websites. I have a couple of people who come in my stream in my community, who are really into amateur radio astronomy. It's not something that I do, although I just had dinner with a friend of mine who's a radio astronomer last weekend, and I'm going to try and get him to come onto the channel and do he. So he's going to talk about what he does. One of the things he works on is the Owens Valley Radio Observatory up in near Bishop in California. Um, but I wanted to have him come on and talk about an introduction to radio astronomy because it's kind of a hard thing to teach, especially if people don't have a background in like Fourier transforms and all that, all that kind of stuff. So so I would say that, and then yeah, just if you Google it, there's a bunch of um, good resources on online for getting started, and then just play around, build your own receiver, build your own antenna, or buy one and just play with it, and you kind of learn as you go. But it's a deep
What's a
subject.
radio telescope for those of us who are not
Oh, so like for
smart?
example, if you look up OVRO, Owens Valley Radio Observatory, it's basically a series of dishes that receive radio signals, and
From
in order to build up a picture of the sky, so they point at the sky, they point at a particular source or whatever,
oh.
and they're typically interferometer. I mean, there are single dish radio observatories that are just receiving radio signals, but they're more typically, I would say, they are interferometers, and so you have a bunch of dishes. Like the VLA is the most famous example, probably that people would know. The Very Large Array, yeah, like contact, exactly like Dr. Doe just said, and so you then use all those antennas together in various combinations called baselines to create a picture of the sky and the radio frequencies, and certain astrophysical phenomena are much more uh they are emitting in the radio.
Oh, okay. Okay. Cool. Yeah,
So it's just another frequency, right? There's like optical, there's infrared, there's X-ray astronomy, UV, and radio is just another part of the electromagnetic spectrum. And we try and observe as many of those things as we can. Some we can't observe from the Earth, some we have to make satellites. UV you can't really do from the surface of the Earth, for example, because we have an atmosphere that's really good at absorbing UV, and the CMB is hard to observe just because of the temperatures and how cold you need the. It can be done, but it's much harder from the surface of the Earth.
so you need the sensors to be colder than,
Yeah, which
so they
is
have to
so
be
everything being in space is
basically
going to be
zero.
close. Yeah, very
Woof.
very low noise amplifier. It's a whole thing. Yeah.
Woof.
No, same radio. I mean, not so Fluffy Bakery, not necessarily like FM radio frequencies, but I don't. Let's see if we can find a picture of the electromagnetic spectrum. Maybe that'll make it clearer. Uh, that's a YouTube. Um, yeah, I don't. If you can find a picture, but the radio frequency is the radio frequency for astronomy is not necessarily the same as like what you're listening to on your FM, like 93.1 here in LA. But
Oh,
that
so
is
it
an
is
issue.
different.
So if you go to some of like I went to the Green Bank Telescope at one point. If you go there, then you have to turn your cell phone off, and there's like a radio quiet area. Um, but you can still, but there's still a lot of interference, and uh, it can be challenging to make the observations when there's other sources,
Wow. And
around.
not even AM radio, just like nothing. Nothing. Or it's not close to
Uh,
AM either. It's like
I
longer
mean,
wavelengths.
no, it's all in the same. I mean, radio is radio, right? Regardless of like whether you're doing astronomy with it or listening to it. Um, but obviously, there's not a ton of point in trying to do radio astronomy at say 93 megahertz when uh, there's a massive transmitter blasting out some radio station 10 miles away. so
Oh,
so
that's
you
fair.
have to
That's true.
so you typically choose your frequencies around uh, the things that you're interested in observing, but then also like what other interference am I going to get and what actual frequencies would be best to use and things like that.
So you can't just turn it on. You have to actually do your research.
Yeah, well, so like radio is, I don't know, 1 centimeter to 10 meters. They're typically longer wavelengths, right?
Mm-hmm.
Um, and above about 10 meters, you're not getting you typically aren't seeing astronomical sources because they're being blocked.
Oh,
And then you go from that at the one end, and then the other end you've got gamma rays and ultraviolet, and then X-rays and ultraviolet and visible, and then infrared, and then radio, and that's kind of like the whole thing. And if you just look up electromagnetic spectrum, you can find any number of
so I have a
eh,
weird question, and
pictures of it.
I don't know if you'd know the answer to this. But right now, if the universe is about 3 Kelvin and we're in the microwave spectrum, where do you think it will be when we do reach nearly zero, or as close to zero as the universe possibly can, if it can't reach absolute zero? And if that's possible, how long do you think it might take?
Well, so that's an interesting question, right? Is the universe just going to go on expanding forever, getting colder and colder? Um, is that expansion going to accelerate? Is it going to slow down? Is there going to be a big crunch? We don't know the answer to that question. Things seem to be pointing right now with the evidence that we have that it's just going to keep expanding forever at an ever decreasing rate. And so yeah, eventually the universe will be, you know, obviously it will still contain the same amount of matter, but the distance between each particle will be so vast that it will essentially be empty. And I don't know,
That's
that's
cool to think about.
how long that's going to take. We're talking about like, billions, hundreds of billions of years. I don't know, but
We won't be around to worry about it. It's
nothing that
just
we're
fun
going to
to
have to
think
worry.
about.
Yeah, right. Climate change is probably the much more likely to kill us than the slow death of the
Oh
universe.
yeah. Oh yeah.
And then what happens after that, right, is interesting. Like, so there have been these theories that the universe expands and then it contracts back. So there's a big bang, and then it expands for a while, and then that expansion slows, stops, and then it comes back, and there's like a big crunch, and so you get this like cyclic universes where it's
That's cool.
anyway. Yeah, that's a whole other thing. But yeah, so
That's really really cool. Radio frequencies are also heavily regulated. Yes, they absolutely are. Hi, Turgis. How are you? So when you after you did your postdoc at JPL, you worked there and you're just kind of like an engineer scientist. What made you leave? Like, I don't know. I feel like, man, if I got a permanent position, I'd be kind
so
of set.
there was a couple of different things that sort of prompted me to leave. One is that we had a baby, and so I took a family leave,
Yep.
and I think I took a month probably when we had our daughter, and so that was that was kind of a pretty big life changing kind of thing that happened. I was like, oh, this is kind of cool. But and then in terms of JPL, so the issue I was having with JPL is just I wasn't doing that much astronomy anymore, right? I had kind of been turned into an engineer, and which is fine, but there's a lot of people at JPL who had been engineers their whole lives and had PhDs in like electronics engineering or very specific um, areas, and it's sort of not supposed to be, but it's kind of a competitive environment, right? If people are looking for somebody to work on their project, you're basically responsible for finding projects to work on and filling up your time card to the point that you're paid for or you're almost paid for. Like if you can get yourself to 90%, the lab will usually be like, okay, fine, we'll cover the other 10%. We'll find something for you to do. But you have to go out and find projects to work on. And so if you're looking for a project to work on and there's not much astronomy going on, then you're kind of becoming an earth scientist. But there's a bunch of people there that have PhDs in earth science. So you're competing with people that have more expertise than you. And you can learn this stuff and but that constant like trying to learn a new skill so that you can be useful can become a little tiring, I'd say, especially when you really just want to do astronomy, right? And so just before I left for family leave, I got moved into a new group called Formulation, and that was working on that would have been working on projects where you were pulling together people from across the lab to work on uh, new big missions or new big, the next Mars explorers or whatever, and you would kind of be in charge of sort of liaising between all these different people, the scientists, the engineers, the business people, and pulling it together and helping make all the connections around the lab. And I actually think that would have been a really cool position, but unfortunately at that point, it was I was leaving on family leave, and then I decided to take an extended family leave, and then my wife's a veterinarian, and she has her own practice and stuff. And we looked at the cost of childcare and stuff, and it was like,
Easy
man,
decision.
I'm basically going to be working to pay for childcare here. uh, and she's much more successful than me, so
Well,
I
vets
ended up
make more
just
money
doing,
than scientists.
yeah,
Period.
well, yeah. And so I just ended up becoming a stay-at-home dad for a while, and that was how me and JPL broke up.
I mean, that's
it
a
wasn't
pretty
it
good
wasn't them, it was
reason.
me.
That's a pretty awesome reason to break up.
Yeah. So, yeah, and then I had like a break from science for a while I was doing that, and I was doing the financial advising thing, uh, and then I just decided I wanted to get back to science, but not maybe in like a formal role necessarily. And so the science communication and outreach and education, and I'd always been interested and excited by getting other people excited about science, and it as how do I put this? It became a bit dark for science, let's say, from the late 2016s, wherever,
Yeah,
like
the past
uh
decade has been a bit dark for
been a bit
us.
rough, and so I figured I would try and do my part to sort of bring a bit of reason and just get people excited about thinking for themselves, like I don't really mind what you think as long as you can justify your position and you can analyze the facts and kind of make your own decisions without someone telling you what you should be thinking. I think that's really important. So, and we talked about this at TwitchCon.
Yeah, it's being able to critically think is so important. We've got some people in chat. Morning, Slug Biker. Yeah, I know, Patrick. Childcare is just stupid. It's not. Yeah. Whole rant. Okay, so we have what are your thoughts about the announced layoffs at JPL? What is your favorite black hole, and where did you go to college?
Uh, okay, so yeah, I went to college, I went to Cambridge in England for my undergrad, and then I went to the University of Illinois for my master's and PhD. Um, Sagittarius A star, favorite black hole for sure, entropic probably. And then layoffs at JPL, yeah, I mean it happened when I was there as well. JPL kind of lives and dies by big missions, so it's famous for some of the biggest, like the Mars rovers, right? These are huge projects with hundreds and hundreds of people working on them, sometimes in shifts 24/7. There's 3 shifts working on these things. There's always people there, and that's great. That brings in a lot of money to the lab and it supports the lab. Unfortunately, if those projects get defunded or downscoped or delayed, there's several hundred people at the lab that all of a sudden don't have a source of funding, and that can be really rough. And unfortunately, the Mars sample return mission was a big thing that JPL was relying on, and that got cut or significantly reduced the funding from the government. And yeah, it's kind of inevitable when that happens that the lab is going to have to uh, is going to have to downsize, and it's just a cycle. It happens every few years. The lab gets bigger and bigger and bigger, and then it kind of contracts, and then it gets bigger and bigger, and it's like this. If you could actually access the data and plot the numbers, I think you would just see this kind of cycle. Um, and
That goes
and
with the big
the
projects.
Yeah, that goes with the big projects and the funding. And of course, all the NASA centers are similar, and they're all competing for these big projects, and especially like Goddard and JPL are always have this kind of friendly rivalry where they're trying to get the big projects. And yeah, it could, and it's really unfortunate. I mean, it is a shame, but it does happen. And the good news for those people is that they have a pretty good resume, probably, and they should be able to find more work. But yeah, it's not losing your job and being laid off is not fun at all. I can tell you.
Yeah, I have a
But
friend who works. She was working on the like photo characterizations of landslides or something, and yeah, of course, Grant runs out. She's out of a job, which kind of
it's
sucks.
I think it's what I was just talking with the friend I had dinner with the other night. He was just reminding me about the brutal nature of proposal season and just that pressure to constantly be writing proposals and bringing in money to justify your existence and pay your salary. And yeah, it's right. People, people, that's sort of part of the hidden thing about science that people don't see is the constant struggle for funding, I think. And that to some extent was a nice thing about JPL, is that there was lots of projects. You were kind of in this environment where there was lots of projects going on, and the big projects are great because you don't have to worry about the funding, right? The funding is coming from the government, and that's you're not if you're working on those projects, you don't have to write grant proposals. You're kind of paid for. The problem is when that funding runs out, as you said, then you're
You should be writing grant proposals in the interim to fund yourself. Apparently, woof.
it's hard to know, right? It's so tough. But yeah, and it that's just the nature of or at least the way that science works here anyway, it seems.
Yeah, I don't know if it's better in other countries. I hope so. But
Yeah, I'm not that familiar. I never worked like in the UK in the academic field, but I'm relatively sure I think it's the same everywhere.
yeah,
Maybe more government funding available, maybe more stable government funding than some of the stuff that goes on here, but I think it maybe if there are scientists from other countries they could chip in. But
yeah, yeah. I would be very interested to know how that works out. So when after you finished like not finished, but when you stopped doing financial advising after you stopped working at JPL and had Mini Nerd, did you start streaming during the pandemic, or when did you start doing science communication?
so I think I started streaming. So during the pandemic, I was watching a lot of Twitch. I was mostly watching gamers, and there was a couple of streams that I went in fairly regularly, and I was kind of part of the community, and we would chit chat. And at some point, it came out that I had worked at NASA, and people were like, "Oh, really? Wow!" And then I'd be asking questions about science and stuff. Occasionally, it would come up, and I'd be like, "Oh, and I would explain things, and they would kind of said, "Oh, you should really start your own channel. I think people would be interested in this." And I was like, "Ah, come on, no one's going to be interested in this." Like some old guy talking about science, like what? Like, uh, and so they kind of talked me into it. And I think I want to say I started in 20. Where are we now? 2024. So I've been streaming for almost 2 years. So 2022, like towards the end of the pandemic, I guess. Uh, Seriously, I like tried to stream gaming for a while during the pandemic. That was a disaster, and I didn't really know what I was. It was just kind of like I was streaming to nobody. I'm like, well, this sucks.
But you
And
gotta
then
cut your teeth. You gotta get
I
the.
know, but nobody tells you that, right? I didn't have a community of people like the science community now, where you tell new people, like, yeah, you're going to be talking to yourself for a while.
That's fair.
And so I gave that up, and then after a few months, they were like, "Hey, you should do the science thing," and I just started, and yeah, it was. I don't know, like I was really stiff, and it was really awkward, and I would hate to see those streams now, but I kind of got into it and I really enjoyed it. And now I have a great community built up, and people who are like, it blows my mind that people are, when they know I'm going to be live, there's people in my chat before I even like start the stream. I'm like, oh my gosh, this is so cool that people are that psyched. And it's still tiny. I mean, I'm still a really small streamer. It's not like I'm huge or anything, but I have a really nice community, and everyone's really jazzed, and we have a nice Discord where we talk about science, offline. And I try and do a mix of stuff, like some of the Lego you can see behind me. We build Lego sometimes, or we'll do like a hardware project. Uh, and just generally try and mix it up, but also keep the science kind of front and center as well. So,
Yeah.
uh,
Thank you so much for the gift, Submandraken. I really appreciate that. And yeah, I just figured it out. Turn the alarms off. I'm just gonna just delete that from this new scene that I just made. Um, yeah.
let me see.
I was like,
That's funny.
Fluffy Bakery, thank you so much for hanging out. Yeah, definitely give Nerduino a follow. I did a shout out about 15 minutes ago, so I can't do another one right now. But yeah.
Let me see
Um,
if I can give you. I'll give you my link tree, and then maybe people can find
yeah.
me because I have started doing.
Is it just Nerduino or is it the Nerduino?
Yeah, it's. I'm not sure. Hold on. Let me see. Because some places the Nerdwino was already taken, which
Yeah,
kind of blew my mind. I'm like, really? Wow.
that's how I felt.
Yeah, but there's always someone out there, right, with the same ideas. And I did have it ready to go because I was like, it would be a useful thing to have. And now apparently I've misplaced it. But yeah, so I have a YouTube channel as well. I post daily videos on the YouTube channel.
It's
Um,
gotta be Nerduino.
just YouTube Shorts. It's the Nerdwino, I think.
Yeah,
On
it's just regular Nerduino. Nerduino. Yes. So his link tree is in the chat. Go give him
Oh,
a
you got the link
follow.
tree. Yeah.
All of the things. All of the things. Um,
Um, and yeah, so I do a daily 60-second YouTube short with like astronomy news and stuff, and those have been going well. Been growing slowly, and I don't know. I can't tell you like I have no idea what the algorithm wants. Some of them seem to go crazy, some of them don't, and they're all published around the same time every day. So I'm still learning. I post them on TikTok and Instagram as well as the same video gets posted everywhere. So just another attempt to try and get people jazzed about science, and maybe like you can't really talk about that much in 60 seconds, but if it gets people to go look at the story and maybe find a story of their own that they think is cool, that's
yeah.
kind of
Any
the
I
idea.
mean
Is
anything you can do to just get people's interest. Like I think both of us are really good examples of finding out what we wanted to do and what we love just completely on accident. Just
for sure.
absolutely
Yeah.
out of the blue, never would have done it in our entire lives had we not fallen into it, you know?
Yeah. Oh, for sure. Yeah. And also, you're still very much in the academic world, and in that the highs and the lows of that, and I'm enjoying being in a slightly different situation. And I think you can do science. You can be a citizen scientist now, right? You can do science in so many different ways. You can contribute to different projects, and it doesn't matter who you are or what you do. You can get involved in science in some way or the other. And whether you have a PhD or you didn't graduate high school, there's things that you can do.
And even if you didn't graduate high school, you can still go get a PhD.
Yep, that's true too.
Mm-hmm. It's a true story.
I'm not sure I would. I'm not sure. That's a tough road though. But yeah,
Well, I'm just saying, I
congratulations.
did it. I wouldn't
I know.
suggest it.
Right.
I would not suggest it. I'm
Possible.
just saying it is possible.
It's
It
possible.
is
Yeah. You can.
possible.
I mean, I hate that. Like people always say, anything's possible if you put your mind to it. It's like clearly that's not true, right? Like I'm never going to play in the NBA. Like
Yeah.
I could put my mind to it as hard as I want. I'm never going to play in the NBA. But there's definitely a lot that you can achieve if you do put your mind to it. So
Yeah, Zooniverse Slug Biker mentioned that. It is a really good citizen science website. You know about that one, right?
which one's that?
Zooniverse?
Oh, yes. Someone told me about it the other day. I haven't spent a lot of time on that, but yeah.
Oh, Mini Nerd would love it. I kept my daughter. So this was like I think it was the first summer during the pandemic, and I kept my daughter busy an entire summer transcribing Australian penal colony records from
Oh,
handwritten into
nice.
digital, and like inputting all of the data about the prisoners and their lives, et cetera, because she's super into history. And so it's like not just science, there's all sorts of projects that anybody can totally help on.
That's really cool. Yeah, I'll definitely. She'll be super into that.
Yeah.
And
Good morning, Chai Latte. Welcome. Thank you so much for gifting those subs, Mandraken. I really appreciate it. And thank you so much for the follow, Tez. You spent so many hours on the Zooniverse looking for skinks. Oh, and a lot of transcription projects. Nice. So what are you doing now, Nerdwino? Other than streaming? Are you wanting to do research? Are you Streaming, doing science. What does the
So
future hold for you?
I don't. That's a good question. That is a good question. So right now, so Mini Nerd is homeschooled right now. So I teach Mini Nerd during the day. Or she kind of teaches herself. Like she has an online platform that she uses, but I kind of manage that. I'm her. As we laugh, I'm the her teacher, the principal, the district superintendent, all those things. Uh, and so I do that. I do the YouTube videos. The shorts actually take surprisingly long between researching the stories and then like doing the script, and it takes a good hour to 2 hours to get those videos out for 60 seconds of content. Is kind of crazy.
It's surprisingly a lot of work to do those. Like I
Yeah,
wish I could keep up, dude, but it's so much.
yeah, it's a lot. And then yeah, just a bunch of other like management stuff. And I would be interested in doing some research. Yeah, for sure. If I could find, and there's groups like the American Association for the Advancement of Science has chapters of people who are not who like have PhDs in whatever area, but they're not currently actively involved
Really?
in academia, and you can join projects there, do research and stuff. And I'm pretty sure if I went down to Caltech, I could probably, and offered like free labor, I could probably find a project to work on. And I may do that when Mini Nerd gets a little older and the homeschool thing is not intended to be like a long term solution. So we'll
Oh
see.
no, it's just I mean, why would you if you have the ability, I think a lot
Yeah.
of parents don't have that ability, but if we're lucky
No,
enough to have
absolutely.
that ability, why not?
Yeah. And I mean, it's a big sacrifice for us because I could be out, working and earning, and we just decided that we were going to do that. And she was in a good school, and anyway, the details don't matter, but it's good. It's really good. And she's really an independent learner as well. So that works out great. And I know a lot of people are like, oh, homeschool, blah, blah, blah. But I mean, she's doing Spanish. She's learning Spanish, which she wouldn't have been learning at school. She does science every day. She does social studies every day. The school she was at, she did science once a week and social studies once a week. And so, and she's doing math, and she does the crunch labs things, and yeah, it's good for her. But
I think there's a lot of things that are necessary for growing up that aren't taught in schools that I think that you can get a lot of experience and stuff outside of the classroom that you're probably offering her, you know?
yeah, exactly. Yeah, and if we just decide one day we're going to go to the zoo or something, right? We just go to the zoo, and she learns as
Yeah.
much as she would have sitting in a classroom somewhere, right? So
It looks like they want a Nerdwino movie.
a movie, oh god.
We do have a question for you in chat. What advice do you have for people who are wanting to start doing SciComm on Twitch?
Oh yeah, that's a really good question. So one thing I would say about that is we talked a lot about this in the panel and at TwitchCon, which is there's a YouTube somewhere. I think on Science has the YouTube on his thing.
Yeah, I've got the panel link. I'll drop it in chat too.
Okay, yeah, drop the link. Watch that because some of the people had really good, like all the panelists had
I
really
wasn't
good comments on how to
avoiding
do that. But
therapy, but I just did.
I would say just start doing it. I think is my advice. Like you don't need a bunch of equipment. Don't buy a new computer and a camera and lights and all this other stuff, right? You at some point you might want to upgrade to that stuff, but just do it with whatever you have. Like if you have a newer cell phone, you can pretty much stream from your cell phone, um, and just kind of try and create some engaging content and build a community. And then if it works out, then you can spend the money on upgrading different things. And so yeah, that would just make it interesting, vary it up, and just accept that you're gonna when you start, it's gonna be pretty brutal, and you're just gonna be talking to yourself. But half of it is just learning to talk to yourself because even when you have 20 people in chat, sometimes people are busy, they're kind of listening, but they're not really interacting, and you just have to get used to the sort of literally creating the content, right? Creating the conversation and keeping the conversation going, which I'm a terrible conversationalist. Like I'm sort of an introvert. I don't really like big crowds of people like TwitchCon, and so that can be a challenge to start with, I think. But I think I've got better, and it's made me a better person, I think, through the streaming as well, and like interacting with chat and learning about people. And I think that's the other thing I would say is talk about science that interests you, and if you're interested, other people will be interested. And there's like there's a lid, as Dr. Nerd says, there's a lid for every pot. So you will find your audience if you just stream what you want to stream. Don't, I think it's easy to fall into the trap of watching some other guy who's like this zany character that has 1,000 redeems and the stream is like exploding all the time and there's things. And if that's you, cool, do that. But if that's not you, don't try and copy that because it's just not going to work.
Yeah, I think I agree. I think that like if you focus on what you want to do and you create your own space and everybody's so different. I think even like with I am sure even with astronomers is the same as with volcano scientists. Like I am an expert in like one little thing and everybody else is going to be very different, you know?
Yeah.
And I think streaming is the exact same. Even if you have two different people who study the same thing. Like, you do
Oh, yeah.
space, Smoodles does space, Astro Connect does space, Astronomy Show does space, and you guys all have different viewpoints and have different things to offer because everybody has a
Yeah.
different background.
100%. Totally different streams. We have overlap, of course, but we also have people who prefer whatever it is, and that's perfectly fine, right? It's great.
Mm-hmm.
I'm a huge believer that the rising tide carries all boats, and the more of us that are doing this, and the more people we can get jazzed. And no, I mean, the TwitchCon last year in San Diego, or the year before, we were talking to people and they were like, "Oh, there's science on Twitch." It's like, yeah, there's science on Twitch, and it was a bit better, I think, this time, and we had the panel and everything. But even still, you could just look at people like Science who have had this front page thing going on for the last couple of months, which is
Mm-hmm.
really cool. But you look at their viewer numbers, and there's huge amounts of people on here who are interested in science and watching science streams that just don't even find it because it's
Yeah,
not.
they just don't know
It's
about it yet.
yeah.
So, cool. Oh, thank you so much for gifting that, Mandraken. We've got some good comments in chat. Yeah, it's definitely good to have reminders about even when we're doing it all the time. It's always good to get reminders on best practices. It's interesting how many introverts do well streaming on Twitch. Yeah, I think it's because I like to hang out with people, but like being in a lot of people can be maybe uncomfortable. I don't know.
Yeah, for sure.
I don't know. Um, yeah, a lot
Or
of
maybe we're just not as introverted as we think we are. That could be
maybe.
too.
I do think that it takes a lot to be more comfortable with yourself. Um, than a lot of people who either don't stream or are just new to streaming have a like very stilted or awkward conversationalist style. And I think that somebody in chat said streaming makes for better conversationalists, and I think it does, but it takes a while.
It does. It does take a while.
Mm-hmm.
Yeah. And I think, yeah, for me, it's become this thing now where like instead of just sort of talking and waiting to talk, someone in chat will say something like, "Oh, I did this," or "I had a bad day," and I'll be like, "Oh, why? What happened?" And I'm just like more interested in other people and what chat's experiences and stuff, as opposed to just talking about science nonstop for an hour, which is maybe not. You got to take a break and
Well, that's what makes I think this is such an amazing platform because we can
yeah,
pause and take questions from chat. Like the and Patrick's only interested in all the non gaming parts, you know,
yeah.
which is
Yeah,
fair.
exactly. And there's tons of great non-gaming parts, right? You got like the food people, the art people, the Lego people, the
Geo Jim in
science
chat, and
people.
thank you for
Yep.
resubscribing.
Tons of, yeah,
Yeah,
exactly. And people supporting the channel with subscriptions and stuff like that really helps too, right? I mean, I think most of us are spending more on streaming than we're getting in like revenue or whatever you want to call it. And so all the subscriptions and stuff really help too.
yeah, they do, they do. I know, like some of us are, some are full time streamers. Not all of us can be full time streamers, but either
Yeah.
way, I think we do all want to put a lot of good into our stream and get the really all what's truly hilarious is the science and tech want to one guide and all the mega streamers say that's the death of a stream. What do you mean by a one guy? What's that mean? Animal rights activists. Hi Ironheart, welcome. Well, cool. Nerduino, what days and times do you stream?
Yep. So currently I'm streaming Mondays, Wednesdays, and Saturdays at 8 p.m. PST. So
Monday,
you can catch
Wednesdays,
me tonight. I'll
Saturdays.
be live tonight at 8 p.m. tonight we will be building. Let's see if I have the thing here. No, that's not it. We'll be building the spaceman Lego. We'll do. We always start with astronomy picture of the day. That's kind of the stream routine, and we look at NASA's APOD website, and we'll drill down and follow down and to see what the photographer used, the equipment, and kind of geek out on that for a bit. Then we'll usually cover a few science stories, space science. Mondays, we tend to focus just on space science. Wednesdays, we'll drift off into environment and climate science and planetary science. And then Saturdays, usually we'll do space science and then um, Lego or a game or something like that. So yeah, that's the schedule for right now. Um, like the link tree, you can get the schedule. Yeah, exactly, you can get the schedule there. And
Thank you, Patrick.
yeah, we'll hopefully see a few people there tonight. Like I said, 8 p.m. and usually I stream for 2 or 3 hours. It just depends. Depends how, and we often get rabbit holed into weird stuff. Like
Yeah.
I don't
So
even know.
I do want to ask you a couple more questions before we go because I know it's early still kind of for us, but I don't know about you. We're getting sunshine, and so I will ditch stream for a sunshine day up in this joint. It's awful
Yeah,
here.
Mini Nerd has a little sailing regatta today, so we're gonna head out here in about. But I have a few more minutes. That's fine. No,
Okay.
no worries.
So I wanted to ask you one question that I always like to ask. What is, and you don't have field work because you're a space scientist, but that would be cool. But like, what is your craziest, just most out of the blue research story or fieldwork story, if you will?
Uh, I mean, so fieldwork. So I did do the I mentioned the flights we were doing in Winnipeg. We had the SMAP, the radiometer slung under a twin otter aircraft, which is this company in Colorado that fits these aircraft out for science, and they also do military stuff. Um, and we were up in Winnipeg doing these test flights, and what we would do is fly over these. We'd start off, we'd fly over a lake, and we would measure the moisture content of the lake because that was like our calibration source, right? We knew that there was 100% moisture, and then we would do this weird like spiral dive where the aircraft was pointed at the sky, or the radiometer was pointed at the sky as the aircraft went down, and it had like half land, half sky, whatever. And of course, these F-18 pilots thought this was hilarious. And then we would fly over the fields, and down in the fields would be people, students and faculty from the university who had taken soil moisture measurements by hand in the fields, and we would compare that to what we got from the radiometer, and we could kind of calibrate the radiometer that way so that we knew once it was on the satellite and going over the Earth and measuring soil moisture that it was accurate. Or whatever or it wasn't accurate and we had to figure out why and all this stuff. Anyway, one night, so I was working with a Scandinavian guy who was like, "Hey, let's go get a beer or two." A beer or two turned into more than a beer or two. I got to
1700 beers later.
Yeah, and so we didn't always fly. If the weather wasn't right or if stuff wasn't happening, it was kind of this long process. You'd get up early in the morning and you'd be like, "No, there's no flying today." Okay. Anyway, I got to bed at like 3 o'clock in the morning, and I got up at 6, I think, and they're like, "Oh yeah, we're flying." I was like, "Okay." So I get on the plane. I'm in the back, like, so we're like, I'm stuck in
Oh
this little seat
no.
behind all these instruments, and we go up, we fly. I'm like, "All right, yeah, this is cool. I feel okay." And then we go over the lake, and then they start the spiral dive thing, and yeah, so nobody knew.
How much
And
was
then
the puke? How much puke?
I got off with the bag, and the pilots just looked at me and they were just cracking up. They're like, "Ah." So that was probably the worst. That was probably my worst field research story.
Yeah, that is. Who drinks more, geologists or physicists?
I mean, we were trying to keep a lid on it that trip because I knew we were going to have to fly. Like we were, but yeah, I wasn't the pilot, so technically I wasn't restricted from drinking. And there was just that one night.
I don't know.
And,
So, but you've worked at JPL, so you've got a good. I don't have very many physicist friends. I've only dated one. Um,
oh,
who do you think
sorry.
drinks more? I know
Uh,
it was only I
Probably
stopped.
geologists. Probably geologists. Yeah.
That's what I was
Yeah.
slightly. We have a issue. Um, cool. Well, thank you so much. I really appreciate you coming on and sharing your stories with us and bearing with their technical difficulties. I really
Absolutely.
appreciate it.
No, no. I always have the same problems when I'm trying to do stream together or whatever it's called now.
Yeah.
But But thanks so much for having me on, and
Yeah,
thanks to chat for all the interesting questions. And yeah, thanks for streaming science and making it interesting here on Twitch. And
yeah, and
I know the
hopefully,
Earth is always giving you new things to talk about, so that's pretty cool.
yeah, I wish it quiet down for a minute, and hopefully we will see you in San Diego.
Yeah, I'm planning on going. I'm just up there. I'm just in LA, so it's a short trip for me. I do have a hotel booked.
Nice,
But yeah, I'm planning on going.
cool.
And if
Well,
anyone else is around, that would be great to meet. We'll for sure have a science meetup and all that stuff, I'm sure.
yes. So we will see you in San Diego. Go catch Nerdwino tonight at 8 o'clock. I think Patrick put his calendar in chat. I don't know if I can shout you out again. Nope, it won't let me.
It's
But
okay.
go
Yeah, no worries.
follow Nerdwino right now. We are going to say goodbye so that he can get to do his Saturday things. And I will see you later. Thank you so much. This has
Awesome.
been
Yeah,
so
no, thank
wonderful.
you. Thanks again. And thanks, chat. Maybe I'll see some of you tonight. All right. Thanks, guys.
Bye.
Bye.